Example 1C is also a difference of squares, and we are going to find the GCF first of all. So the GCF for C is 1, which means we can go ahead and proceed to see if it factors further. It is a difference of squares. Z to the 4th is a perfect square. 81 is a perfect square, and we verify the square root of each. So the square root of Z to the 4th is Z squared. The square root of 81 is 9. So this is going to follow the conjugate a plus b times a minus b, where z squared is a, 9 is b, and we put in that in parentheses z squared plus 9 times z squared minus 9. And this actually does not complete the answer. Z squared plus 9, that cannot factor further. That is a sum of squares, and a sum of squares does not factor further. Z squared minus 9, however, is a difference of squares, and a difference of squares factors further. And so we verify that by taking the square root of each term. Z squared is z. The square root of 9 is 3. So z squared minus 9 can factor further, and that factors into z plus 3 times z minus 3. And we do need to bring the z squared plus 9 that doesn't factor further in front of it. So z squared plus 9, and that gives you your final factored form, the final answer. And so that's example 1C.